Welcome to the AMTC 2021 interview series. In this episode, I'll be talking to Jörg Spindler from Audi. Hi, Jörg. Thank you so much for joining me today.
Hello, Rachel.
So let's just, if we can start off with a little bit of information and maybe some insight from you about your role at Audi and how your experience at the company has resulted in what you're doing now.
Okay. At the beginning, I started mechanical engineering at the University of Stuttgart, also technology development. And then I started at Audi in the planning department in Ingolstadt and got different leading positions at the different plants, Ingolstadt, Neckarsulm, also Bratislava in Slovakia at VW Group, in leading positions for the tool shop, for the planning department, in the end also for the press shops of the Audi Group. And at the moment, I'm the head of the planning department, of the tool shops, of the group, and also of the technology development.
So your experience is very manufacturing based.
Yeah, especially manufacturing based.
Good.
Nearly only, yeah. But okay, that's the main point, yeah.
Okay, so with that experience, when were you first introduced to additive manufacturing as a production technology, and can you explain Audi's approach to the technology set?
Okay. Audi started about 20 years ago with polymer additive manufacturing systems, the first tests, and about 10 years ago with metal additive manufacturing. And I was there from the beginning on with the metal additive manufacturing, and we printed few showcases, few parts, just to show what's possible. And we had this first machines we bought. We used on one time with the tool shop to do it productive. Mm-hmm. And on the other hand, with the technology development to just develop materials, processes, and so on.
Applications. The specific applications for end-use parts or for the tooling?
Okay.
Or both?
We do both. We did first parts for prototypes for the cars.
Yes,
of course, but only for very small numbers of cars.
Yes.
And on the other hand, we did parts for tools. First, at the tooling process for the press shops, we did very small parts where you normally have to do a lot of subtractive manufacturing, where you have a lot of waste material after the process. And then we try to do it with the additive manufacturing to reduce material at the beginning, or do very small parts where are very complicated to produce in another way. And now we are going to the next step, to the fourth dimension, I will tell. It's that we use the cooling systems inside the tools, near the surface of the tools. And there are some processes in the production of cars where you have a real advantage if you can use this fourth dimension.
The fourth dimension?
Fourth dimension means an add-on, which is not possible to do in another way.
Okay.
So normally you have three dimensions,
yes,
it's a normal
yes.
thing. And now you have a cooling system that is very near and the surface of the tool. And if you have hot forming processes or casting processes, you need to have a good cooling system inside your tool. So you have advantages in the process afterwards, in the production itself. And then we are talking about the fourth dimension. It's something add-on, not only three dimension, something add-on. Yeah.
Okay, so I was actually going to ask you, and I guess that's a key point to my next question in terms of what are the main drivers for Audi when it comes to additive manufacturing, and have you moved past that sort of complexity for tooling into final production parts?
Okay, the main drivers, in the end, it's all about money, I have to say.
Really?
We're a company who has to produce very good cars to a good price because the customers just want to pay a good price and not a very expensive price. So in the end, we have to think about the costs, costs in total cost of ownership, not only the production of the first part. So you have to differentiate if we use these parts printed, 3D printed, in the car itself.
Yeah.
It just works for very small series, pre-series, or...
so the volumes aren't there for you yet?
Yeah.
Right.
Very low volumes, or in the first part of the development of the car itself. And the other thing is to use it in tools, where you have an advantage, not at the first step if you produce this part of the tool, but in the process afterwards. You asked me if we really use these cases already right now. We did a special part inside a casting process, and it was more expensive to produce this part for the tool in the casting process. But in the process itself,
the lifetime.
Over the lifetime, we had a good business case because the process time we could shorten at 15 seconds. So after a number of parts we produced in the lifetime of the tool, we got the break-even point, and then we earned money. That's the way.
That's really interesting.
It doesn't have to be directly in the first step cheaper, but in the total lifetime of the tool or the part, it has to be cheaper. If you think about the airplanes, if you produce parts which are lighter, they are probably more expensive, but the airplane needs a lot of petrol to fly, and if you can reduce the petrol because the airplane is lighter, then you will reach the break-even point a few years later after a lot of stops and flights of the plane itself.
And I guess assessing that over the lifetime, that's quite an interesting thing to do, and I guess that's where you will get the better returns.
Then it works. Then it works. Or you use this technology if you can't do it in another way. For example, we will have a very, very beautiful next car in 2 years, and we haven't been able to produce these cars. There was a special design feature, and we haven't been able to do it. And then one came to the idea, we need a special tool for the body shop. And then he said, okay, let's print this part. We can't produce it, but with this special tool, we are able to realize that design. So it's a little bit more expensive. In this case, the costs are not very interesting. In this case, it's the idea, the target to realize that beautiful design that our customers want to buy the car.
So in terms of insight into that application, the process that you're using and the materials that you're using, can you talk a little bit about that?
We develop also the materials. Sometimes we get new materials. Suppliers tell us they have new advantages with new materials. We take the materials, we make tests. We also working on the process, how to work with these materials, how to go with the machines. Every machine we first bought from a supplier is differentiated by ourselves. And to bring the best result, you have to know the whole process of the process chain to produce, starting with the software, starting with the engineering, starting with the parameters of the machine itself, starting with also the material, as you told. And so we develop also materials. At the moment, we are using aluminium and steel materials, steel for the tools, aluminium especially for the prototype for cars.
Okay, that makes a lot of sense. And obviously, it's all about metal AM. But is it the laser powder bed fusion process that you're using, or is it?
Well, it's a laser process we are using for the metal AM. For the polymer AM, we have also a department, not in my responsibility. It's a little bit bigger. They do a huge part of parts for the early steps of producing the car, for the pre-series. And also we use it in every plant, the polymer additive manufacturing, to produce parts to help the guys to produce the car. So very easy things that the process is easier for the workman.
So just to round up then, are there any specific trends that you see emerging at the moment around additive manufacturing that make you excited?
Okay, at the beginning, there was the idea we can do everything. Now I think we know you can't do everything and you can't do very big numbers. Then we focused on to do very parts which have no weight. We are very light. And next step is this 4-dimension. And I think in the future, if we are able to do electronic components in polymer parts, that will be the future. This would be the next big step, not in the metal part. Metal part, I just told, cooling systems, etc. But the combination between plastic parts and copper or other metal parts inside. And this combination would be the next step, I think.
I think that's quite a positive note to end on. So, Jörg, thank you so much for your time today.
Okay, it was a pleasure. Thank you. Bye, Rachel.